Hey everyone, welcome back to another session with OneClass. My name is Bassam, I'm an engineering graduate, and today we're going to be going through some math problems at the high school and preliminary university level. So let's get started over here. Okay, so the first question here is about conjugate math. So to describe what this is, essentially if we had x plus y, the conjugate of that would always just be flipping the sign, so x minus y. Similarly, we can take the example of imaginary numbers, so a plus bi. So this is the format of an imaginary coordinate. The conjugate of this is a minus bi. So one thing to note is whenever we have an imaginary root, we always have the conjugate. So conjugate math is useful in that scenario. Let's go through a simple example here. So let's say we had 5 over 7 minus square root 3. The question asked us to kind of simplify this down and remove the square root from the bottom, so remove it from the denominator. We would multiply this fraction by the conjugate form, which would be 7 plus square root 3. And then because we're multiplying the bottom by this value, we also would want to multiply the top so we don't change the original fraction. So we'll multiply the top as well by 7 plus root 3. So this is technically just 1 equal to 1. So we just multiplied the original fraction by 1. And this represents the conjugate of this. So we'll go through the math just to show you how this simplifies. So we have 5 times 7, which would give us, let me just erase this. So 5 times 7 will give us 35, and then we have plus 5 times square root 3. And then on the bottom here, we know that this right here is a difference of squares. So this is kind of in a similar format for the difference of squares. The difference of squares is a squared minus b squared is equal to a minus b times a plus b. So we'll use that here. So we know it will be 7 squared minus square root 3 squared. And then this will give us 35 plus 5, So 35 plus 5 square root 3. And we have 49 minus 3. So square root 3 squared is just 3. And then we end up with 35 plus 5 square root 3 over 46. And we've eliminated the square root in the denominator, and we've gotten the final form here. So that's just an example of where conjugate math is useful. So the answer here describes conjugate math correctly. So it gives the example x plus y and x minus y. Explanation is correct. All right, let's get to the next question. So here the question is asking complete the table of values and then plot the ordered pairs, and it's giving us a function. So we have the function x minus 2y equals 2. Okay. So it doesn't really provide us with a table or an image of a table, so we can just plot the function here and substitute values of our own. So the best way to start off is to put the equation in the format of y equals mx plus b. where m is the slope of the function and b is the y-intercept. So we'll rearrange the equation. So we have negative 2y is equal to 2 minus x, and we have y, we divide negative 2 on both sides, so we get 2 minus x over negative 2, and then this will give us 2 divided by negative 2 is just negative 1, and then negative x divided by negative 2 is positive a half x. So we have y equals 1/2 x minus 1. So we'll clear the page. So we'll write this again, y equals 1/2 x minus 1. So if we wanted to plot this, I'll just draw a plot here. We have x, we have y. We can start off by noting that the slope is a half, and we know that the y-intercept is negative 1. So the easiest value to sub in is x equals 0. So for this is where the y-intercept exists. So when we substitute x equals 0, we'll get y equals negative 1. So we know at x equals 0, sorry, negative 1. So this is negative 1. So we know there's a point on the function there. We can also go on and just substitute just values of 1, 2, 3, 4, and that will give us more detail. So at x equals 1, we'll get a half times 1 minus 1, and that will give us, so we'll have here a half minus 1, which will just be negative a half, and that will equal y. So at x equals 1, so 1 right here, we get negative a half. So negative a half should be right there. That's the second point. And then we'll do this for x equals 2. So we have a half times 2, which is, so we'll do half times 2, which is just 1, minus 1 will give us 0. So at 2, we have 0. So we can see that this is just a linear, this function represents just a linear plot, so we know it'll go something like this. That will be the function. We can add in more points, so at, let's say x equals to 3, if we substitute 3 we get 3 halves, and 3 halves minus 1 is just a half, so this point will be there, so that will be at about a half. And then the next point at 4, so we substitute 4 into x, we get 2. 2 minus 1 will give us 1, so we know the next point is on here. And we know that our calculations are correct. So that's kind of how to plot the graph or the function on the xy coordinates for that function. Okay, so looking at the answer here, calculate various points by assuming x value and respective y value according to x. Complete table of that and plot. So there's no plot presented, no plot presented. Process is correct. However, incomplete solution. So it's not a full solution presented by the student or tutor. Okay, so the next question here is asking us what is 10 to the 5th power? So 10 to the 5th is just 10 to the power 5. And I guess for any kind of value, for any value a to the power of b, let's say, we would have a times itself, b times. So let's say b was equal to 3 here, it would be times a times a. So if b was equal to 3, that means we know a to the b is equal to a times a times a. So we'll apply the same idea here. So 10 to the 5. So we know because it's the power of 5, we know it'll be equal to 10 times 10 times 10 times 10. That's 4 10s, so one more 10. And then whenever we multiply 10s together, you essentially just count the numbers here. So here we have 5 zeros. So we write a 1 and we put 5 zeros after. So we know we get 100,000. Another way just to go from this step to this step right away, you can, if it's 10 to the power of something, then you can just write 5 zeros knowing that this value is 5. If it, let's say it was 2 to the power of 5, then it would just be 2 times 2 times 2 times 2 times 2. So there's 2 times itself 5 times. So maybe this might be harder to calculate because it's just not just putting zeros after the 1. So you could do this kind of separately. You can do 2 times 2 is 4, and then times 2 again, and times 2 times 2, and then we get 4 times 2 is 8, and then we know the last 2 times 2 is 4. So this is 4, and this is 8. And then we know 8 times 4, 8 times 8, sorry, 8 plus 8 is just 16, and then 16 twice is 32. So 8 times 4 is 32. So the solution is correct here. The solution also goes down to further describe what 10 to the 4. So similar idea, we have 4 zeros, 10 times itself 4 times, and then 10 to the 6 as well will give us 6 zeros. So this is a million. So correct solution, great job. Okay, so the next question we have here is an investing math question. Harry wishes to invest $2,800 into a savings account at his bank. His bank offers an interest rate of 5.96, compounded semi-annually. So I'll just write that down. He invests $2,800, and the interest rate is 5.96%. And then compounded semi-annually. So I'll just write semi. I'll just write semi for semi-annually. And then Harry's friend, Ida, invests $2,000 into a savings account at her bank. The bank offers her an interest rate of 7% compounded semi-annually. So they're both compounded semi-annually. She has $2,000, and then 7% is her interest rate. And then the question asks, after how many years will Ida's investment be worth as much as Harry's? So what we need for this equation is kind of the equation for interest rate and linking principal amount to the total accumulated amount. And that equation is as follows. A equals P times 1 plus R over N to the power of N times T. So A is the accumulated total value. So after that period of time, A represents the total value that we've accumulated. P is the principal amount. P is what you've initially invested. So in this case, it's $2,800 for Harry and $2,000 for Ida. And then this is just the 1, and then R is the interest rate. So whatever the interest rate given here. So it's 5.96 for Harry, 7% for Ida. And then N is the number of times the amount is compounded per T, per time period T. So T is usually represented in years. So because T is represented in years, we know that semi-annually gives us N equals 2, because for each year, the amount is compounded twice. And then for T, is what we're trying to solve, because that's what the question is asking. After how many years will Ida's investment be worth as much as Harry's? And we want to see at what point will let's add two more variables. So we'll say AH is equal to AI. So at one point will AH equal AI? So we can clear some space here. And we'll write out as follows. So we know AH is equal to the principal, which is 2,800. Let's double check. Yep, 2,800 for Harry. And then we have times 1 plus 0.0596. And then divided by 2 to the power of 2t. Oh, that's behind the camera here. So that's for Harry. So I just write this a little clearer. So times 2t. And then for Ida, we have AI equals 2,000 times 1 plus 7%, which is represented by 0.07, and divided by 2. And then we have n, which is also 2 for both, and then we have t. So here we set AH equal to AI, and we'll get the following. So we'll have, let's say AH equals AI, and we have 2,800, 1 plus 0.0596 divided by 2, 2t. And then actually, we can just calculate what this is using our calculator. So 1 plus 0.0596 divided by 2, that will give us 1.0298, and we'll set that equal to 2,000. And then we can also calculate this value. So 1 plus 0.07 divided by 2 is 1.035 to the power of 2t. Okay, so now we divide both sides by 2,000. So essentially you want to take the 2,000 and 2,800 and put them on the same side. So we'll get 2,800 over 2,000. And then we'll move this to the other side by dividing it by both sides. So this gets eliminated on one side. So we'll have 1.035 to the power of 2t divided by 1.0298 to the power of 2t. So because there's 2t on the bottom and the top, we know we can write this as all of it to the power of 2t. So now I'll move this to the top. So now we have 2,800 divided by 2,000, and that will give us 1.4. And that will be equal to 1.035 over 1.0298 2t. So to solve for the exponent, we have to take the log of both sides. So we know log 1.4 equals 2t log 1.035 over 298, sorry. And then we isolate for t, so we have, we'll say t on the right side. So let's keep t on the right side here for now, so it's a little more clear. So we'll say t equals, and we'll divide everything to the other side. So we'll divide by 2 log to the 1.035 divided by 1.0298. So we'll have log 1.4, which was already on the left side. We'll divide by 2 log 1.035 1.0298. And then we'll end up with t equals, so this is just a matter of plugging in to our calculator. So we have log 1.4 divided by 2 log 1.035 divided by 1.0298. And then we'll get approximately 33.4 years. So knowing this, this kind of answers our question, after how many years will Ida's investment be worth as much Harry? So we can say after 33.4 years, Ida's investment will be the same as Harry's. So to double check this, we can go back up to our original equations. We can double check this by plugging in 33.4 into this equation and this equation. And we can see what values we get for AH and AI. So I'll just calculate this down here. So if you plug it into your calculator, you'll get AH will equal 19909.1, and AI equals 19908.8. So I've already done this, I've already plugged these in. So you can see that these numbers are very close. The reason they're off by a little bit is because this was an approximation, because there was more decimal places over here, but I just didn't write them down. So these two are essentially equivalent when 33.4 years has passed. So both their investments are the same. So there's no PDF attached, so no solution attached. Incorrect. Actually, the correct answer is 33.4 years. So the next question is asking us to define the property of equality under addition, subtraction, multiplication, and division. So let's say we had A plus equals to B, and then C equals to D. So there's 4 scenarios. Let's say we added these. Let me just write a better D here. So let's say we added these. If we were to add these, we would get the following: A plus C on the left side, and then this would be equal to B plus D on the right side. So it doesn't really matter if B or D comes first or A or C comes first. Just remember when you're adding these to keep the variables on the left side on the same side, and then the variables on the right side also on the right side. And then for subtraction, so we'll say this is the scenario for addition. For subtraction, we'd have A minus C, B minus D. So here the position of B and D is important. If we're subtracting equation 1 from equation, if we're subtracting 1 minus 2, we would get this. If we did 2 minus 1, so equation 2 minus 1, equation 1, we would get the opposite. So we would get C minus A equals D minus B. And then the position of D and B and A and C would matter here. Okay, and then for the next scenario, for multiplication, we would have A times C is equal to B times D. So this is also pretty straightforward. The position of A and C don't matter, just make sure to keep them on the left side. A and C on the left side and B and D are on the right side, as shown here. And then finally, for division, we have A divided by C is equal to B divided by D. So in this scenario, we know C and D cannot be 0. So C and D cannot be equal to 0, otherwise we do not get a valid equation. And then here, A has to be on the top. So if you're dividing 1 divided by 2, A would have to be on top, and then C would have to be on the bottom, but they're both still on the left side. And then similarly for B and D on the right side. If you're doing it the other way around, if you're dividing 2 divided by 1, then these two would flip, and these two would flip. So you would get C over A is equals to D over B. So looking at the solution here. So here they outline subtraction. So the emphasize here kind of multiplying by a constant. So here if you multiply A equals to B by a constant, then you would get CA, CB. So we'll make some space down here. So if we were to multiply C times A equals B, we would get CA equals to CB. And then similarly, if we were to have A equals B divided by a constant C, we would get A over C equals B over C. So it applies to both sides of the equation in this scenario. And then here, C cannot equal to 0. So the solution here is correct. Okay, so the question here, what causes a solution to a rational equation to be an extraneous solution? When there is, and it gives us 4 options. Excuse me. Okay, so the first option is when there is more than one solution, one of the solutions is extraneous. If a solution results in 0 when substituted into the denominator of the equation, the solution is extraneous. If a solution results in a negative number, when substituted into the denominator of the equation, the solution is extraneous. And then when a solution is a fraction, the solution is extraneous. So here we have 4 options. And then here it goes through an example. So we'll take the example here and we'll run through it to kind of show you why. So if we had 1 x minus 2 and then 1 plus 1 x plus 2, and then this is equals to 4 over x minus 2 x plus 2. So this will help us understand which option above is correct. So here to solve for x, we want to find a common denominator for all values. So here we would have x plus 2. So we multiply the first component by x plus 2 on the top and bottom. So we end up with x plus 2 on top. And then we have the same denominator on the bottom. And then additionally, if we multiply this component by x minus 2 on top and bottom, we'll get with x minus 2 on top, and then we'll have for both x minus 2, x plus 2. So all we did is find the common denominator and do this for all components of the equation. And then here, because we have a common denominator, we kind of eliminate the common denominator and we just solve for the top part of the equation. So we have 2x is equal to 4. So the 2's cancel out and we end up with 2x equals to 4, and then we have x equals to 2. So in this scenario, because we've canceled out the denominator to solve, we always have to pay attention to the denominator. If we ever cancel out one of these components on the bottom, so a root at the bottom, then we have to kind of keep note of that, because we know if we plugged in 2 to the top equation, we will get 2 minus 2 is equal to 0, and we can't divide by 0, so we don't get a correct solution, and the solution is extraneous. So to keep track of this, you have to say x cannot equal to plus or minus 2. So because we've eliminated them from the denominator to solve, we have to say that x cannot equal plus or minus 2, because if we plug these values into the original equation, we would divide by 0, and that would give us an extraneous solution. So here we would say this is not a correct solution, and the solution does not exist. So here goes through the same process, plugs it back into the original equation, and because we're dividing, we can see that we will not get a finite result from above, as the denominator will be 0. From here, we consider the option 2 is right. So option 2 above says if a solution results in 0 when substituting into the denominator of the equation, the solution is extraneous. So that's correct. So essentially, if our solution is 2 and we substitute it back and the denominator becomes 0, so the solution is extraneous. So to look at the other options, when there is more than one solution, one of the solutions is extraneous. That's incorrect, because there are some scenarios where we have multiple solutions. If a solution results in a negative number, when substituted into the denominator of the equation, the solution is extraneous. That's incorrect, because we can have negative number solutions. When a solution is a fraction, the solution is extraneous. So that's also incorrect, because we can have fractions as solutions. So option 2 is correct. So correct option selected, great job. So the next question we're asked is, what is the integral of CosX? So the integral I is equal to any function dx. This is kind of the format you would represent the integral. If we were to evaluate the integral for CosX, the integral of that is sine x. So this is kind of something you just have to memorize. There's a longer derivation for this, but this is one of an important key kind of integrals to memorize, that the integral of CosX is sine x plus a constant. So also, if we take the derivative of sine x, we would get cos x. Additionally, if we take the integral of sine x, we would actually get negative cos x. And then if we take the derivative of cos x, if we took the derivative of this, we would get negative sine x. So these are kind of, so this is kind of just an important integral to memorize. So just give me a second here. Okay, so yeah, and then the one thing I forgot is to add the constant down here. So whenever we integrate, we have to add a constant at the end. So looking at the solution here is correct. go on to the next question. So it's asking us how much is 168 centimeters in feet and inches. So we can start off here and say 168 centimeters, just write that down. And we want to convert this to feet and inches. So usually here we would want to use conversion factors. So a common conversion factor known for the conversion of centimeters to inches is that for every 1 inch, that is equivalent to 2.54 centimeters. So this is a very common conversion rate used for converting between the metric system and the imperial system. So here we could say that 168 centimeters, and we multiply it by the conversion rate, and then this would be 2.54 centimeters on the bottom, because we want the centimeters to cancel out, and we want to end up with inches, and then 1 inch on top. So initially we're converting to inches because this is just an easier conversion factor to work with. So 168 divided by 2.54, that'll give us 66, and I'll keep 2 decimal places, 0.14, and that'll be inches. And then another conversion factor that we can use is 12 inches equals 1 foot. And then we can multiply 66.14 by that rate. So 66.14 inches times 12 inches on the bottom and 1 foot on top. And here we can see that the inches cancel out, and we end up with, so we'll take 66.14 divided by 12, and that will give us 5.5, let's say 5.51 feet. So we're getting close to the final form. We want to represent this in feet and inches. So we know we have 5 feet, but we just want to convert the decimal points after that to inches. So we can take 12 inches and just multiply that by 0.51. We know that it's going to be 5 feet and something inches. So to calculate what that something is, we just take 12 inches, that's how many inches are in a foot, and multiply that by 0.51, the remaining amount. And then that will give us 12 times 0.51. That'll give us 6.12. So we can say it is 5 feet and approximately 6 inches. So approximately. Okay, so looking at the solution here provided, so they use the 2.54 conversion rate, they get 66.1 inches, and they get 5 feet and 6.14 inches. So yep, we got a similar amount. So our answer might be a little bit off with this decimal spot because we didn't take as many decimal places in previous calculations, but both answers are correct, depending on what the question is stating. So if the question was stating to add more decimal places, then you would try to keep more decimal places as you're doing the calculation. So here another example is given in the solution. What's 150 centimeters in feet and inches? So a similar process is followed to multiply through. And they get 4 feet and 11 inches. So yeah, they go through a similar process to do kind of example calculation, and they convert 100 centimeters as well. So here 100 centimeters multiplied by 0.3937, which is just 1 over 2.54. So the same conversion factor that we used up here. And we get 39.37, and then there's 12 inches in feet, so 3 feet is equal to 36 inches. So they kind of just subtract it out, and then the remaining is 3.37 inches. So you can do it both ways. You can just multiply the decimal point by 12 inches, or you can kind of just subtract out from this. So you can do multiples of 12 until you can just subtract out. You can't subtract out any more multiples of 12. So correct answer. Great job. Okay, so we're on to the next question. So this question is asking about the zero exponent. So any value a, so it can be any value 2, 3, 4, 5, any number to the power of 0. What is that equivalent to? So for any number to the power of 0, it's equal to 0. Sorry, not 0. What am I saying here? It's equal to 1. Anything raised to the power of 0 is equal to 1. So even if we had like a huge number to the power of 0, this would still be equal to 1. Regardless of what the number is, we could have 2 to the power of 0 equals 1, 1 to the power of 0 equals 1, and so on. We can have 20 to the power of 0 will also equal 1. So here looking at the solution, the zero exponents rule, one of the rules that will help us simplify exponents. So yeah, this is another good example to show. So if we have 2 over 2, 2 divided by 2, we know for sure that is equal to 1. But we could also split this out to say that 2 to the power of 1, so this part on top, multiplied by 2 to the negative 1. So we know anything in negative 1, you just put it in the denominator, like so here. So this is equal to 2 over 2. And then if we were to add the exponents, because they're being multiplied together, if we just added the exponents, we would end up with 2 to the power of 0, which would still be equal to 2 to the 2. And we know 2 to the 2 is equal to 1, so is 2 to the power of 0. They're both equal to 1. So a to the 0, any number to the power of 0, is always equals to 1. So this is a very important rule to know when you're simplifying variables and equations. So this is the correct explanation. Great job. Okay, so we have another question over here. So here we are asked the derivative of log x. So d dx of log, we'll say a to the x. Usually if you say log x, you're assuming that there is it's log to the 10x. So similarly with ln x is essentially just log to the ex. So same idea here. So here we'll say we'll just put in the variable a. Knowing this, the derivative of log x is 1 over x ln a. So this can also be derived from going through the limit method, but this is also a very useful derivative to just have memorized. So here we know for, let's say if we substitute in log x, so we know log x has a base 10 here. So we know the derivative of log base 10x is equal to 1 over x ln 10. Here, ln 10, you can just plug that into your calculator, and that will give you 2.3025 and so on. And then you would just have 1 over 2.3025 So 3x. So this is kind of a simple format to represent log 10x, the derivative of that. Or you could just leave it as log 10 if you're doing further calculations to solve for, let's say, the variable x or something like that. So here in our question, base is not given. When the base is not given, then we let that the base to be 10. So if the base is not given, we assume that the base is 10. So yeah, the derivative is correct here. So, rate solution is correct. So the next question, the area of a rhombus is 484 square millimeters. One diagonal is 1/2 as long as the other diagonal. Find the length of each diagonal. So we know a rhombus is just something like this. These sides are parallel, and these sides are parallel. Let me just double check something. And additionally, for a rhombus, all sides are equivalent. So they're equivalent length. But the question here is mostly asking us for the diagonal. So the diagonal here and the diagonal here. These are kind of how the givens are represented. So the first diagonal, so let me change the color here. So we'll say this diagonal, we'll represent that as the variable p, and then for this diagonal, we'll represent that as the variable q. And then for the equation of area, because we know that the area is 484 millimeters squared, so 484 equals area. The area of the rhombus is just PQ, so each diagonal divided by 2. So we've defined one equation for the question. The second information that we're given, one diagonal is 1/2 as long as the other diagonal. So one diagonal, so P multiplied by 1/2 is equal to Q. So half of P is equal to Q here. So we know that that's kind of how to represent the information given here in equation. So we have two equations, equation 1 and 2, and then two unknowns for P and Q. So we have to just plug them in and solve. So if we substitute equation 2, Q into the equation 1, we'll get 484 equals P times 1/2 P over 2. And then this gives us 484, 2P on top, and then actually, no. This would give us so I believe P squared over 4. So having that value, so we have P times P, so multiplying the two P's will give us P squared, and then we have the half, so we can take the 2 and just put it at the bottom of this fraction, and then that will give us 4 on the bottom. And then we multiply 4 by both sides of the equation, so 484 times 4 is 1936 equals P, and then P squared, sorry, and then P equals the square root of that, square root of 1936, which equals 44. So we know P here equals 44, and then we use this equation to get Q. So Q equals half P. That gives us a half of 44, which is 22 millimeters, because the area is in millimeters squared, so we know it's 44 millimeters and 22 millimeters. So looking at the equation here, so we represent sides D1 and D2. They have the correct area for a rhombus, and then they have D1, which is P in our diagram above. So P here is 44, and then Q is 22. So the student found the same correct answer. Answer is correct. Great job. Okay, so the next question is asking us the terminal side of an angle in standard position passes through P, -3, so the point -3 and -4 on the xy plane. What is the value of tan of that angle? So let's draw out the plane here. So we have x and y, and we have the point -3, -4. And we want to know what is tan theta. So we can just look at our plot here. So -3 over would be here, and then 1, 2, 3, 4. So our point would be somewhere over here. And then we have kind of something like that. And we want to know what the value of tan theta. So usually when you're doing this, for tan, we know the mnemonic SOHCAHTOA, so SOHCAHTOA. Here, TOA is tangent is equal to opposite over hypotenuse, so we know tan theta is equal to opposite over hypotenuse. And then looking at this, we can kind of draw we want to look at the angle between the x-axis and the line that I drew. And then we know that this side is 3 and this side is 4 for this right angle triangle. So we know if we did tan theta, we would know it would be opposite, so 4. So tan theta is opposite 4 over adjacent, which is 3. So seeing that this is -3 and -4, we know it's -3 and -4, but because there's negatives on top and bottom, we know these cancel out. And we are left with +4 over +3. So another way to think about the angle is, for this diagram, is the acronym CAST. So we know when we're evaluating for sine theta, cos theta, and tan theta, we can use the acronym CAST. So CAC, I'll just change the color, CAST for each region on the diagram. So the acronym, the mnemonic says C represents cosine. So for all cos theta, the value is positive. And then A is for all. So sine theta, cos theta, and tan theta are all positive. S is sine theta in this region. So the region 2 here. So this is region 1, 2, 3, 4. So in region 2, sine theta is always positive, and in region 3, tan theta is always positive. So we know our tan theta is always positive here. and we have 4 over 3 as the solution for tan theta. If we had if we had essentially a different point, if we had -3 and 4, we would still have 4 over 3, but it would be -4 over 3 because we're in the S, which means that tan would be negative and only sine theta would be negative. So in region 2, sine is positive, tan and cos are negative. In region 3, tan is positive, sine, cos, theta are negative. In region 4, cos theta is positive, sine theta and tan theta are negative. And then in region 1, all sine theta, cos theta, and tan theta are always positive. So looking at the solution here, so they draw a similar point, do a same calculation, -4 divided by -3, and they get 4 over 3 for tan theta. So solution is correct. Okay. So that's the end of the session for today. If you have any more questions, you can always visit the link in the description or go to oneclass.com for any homework help or tutoring. I'll see you in the next math session. Goodbye for now.